Assalamualaikum and hello everybody. So today we continue mechanics of materials for chapter 5, analysis of beams for bending. In chapter 1 until chapter 4 we already learned about how to analyze the elements. For this chapter we will learn about analysis of beams. Beam is one of the main structure of the building, so that's why the analysis of beam is very important. So in this chapter you will learn the fundamental concept on how to analyze the beam. We take a look at the learning outcome. By the end of the chapter, you should be able to calculate deviations at support for simply supported, cantilever or overhanging beams, analyze the beam to evaluate the shear force and bending moment due to various loadings by using moment equation, and also graphical technique due to various loadings. Draw the shear force and bending moment diagram. Locate the maximum shear force and bending moment and also their location. As I mentioned in class, you have two methods to analyze the beam, which is by equation and also by graphical techniques. Equation will be come out in your midterm exam, while graphical technique will be come out in your final exam. Okay, so you have two methods to calculate the maximum moment and also shear maximum. As for introduction, beam is a member with support loadings applied perpendicular to the longitudinal axis. Beams are subjected to a variety of loading patterns such as normal concentrated load, inclined concentrated load, uniformly distributed loads, linear distributed loads, and also applied moment. So as in the figure here, so this is the beam, and here the vertical structure here is a column. So in this chapter we will analyze the beam, while in chapter 9 later we will learn how to analyze the column. So for the loadings here, you already learned in chapter 1 how to analyze all these loadings. So just a refreshment from what we have learned in chapter 1. What is a normal concentrated load? A normal concentrated load is one that acts perpendicular to the major axis of the beam and only at a point. So this is your load and it's only at this point because it is a concentrated load. For inclined concentrated load, it may have some angle here. So how to solve for inclined concentrated load? You have to resolve by y and x direction. So you need to know which one is a cos and also which one is a sine. We also have a uniformly distributed load. A uniformly distributed load is a load of a constant magnitude acting perpendicular to the beam. So this is a magnitude. The unit is kilonewton per meter or newton per meter, depends on the given equation. So this is a uniform distributed load. What does it mean by uniform? Means that the magnitude at this point, this point, this point, this point, and this point is same. Okay, uniform means that the magnitude is same throughout the loadings. But different with uniform, for linearly distributed load, the loads is varying. It have a vary magnitude, minimum magnitude until a maximum magnitude. How about this point? What is the magnitude of this point? How about this point? So you have to do the ratio. Remember the ratio that I've already teach you in chapter 1. We have the triangle and we also have a trapezoid. The shape of the linear distributed load, we have triangle and also trapezoid. We also have a concentrated moment, which is an applied moment. It tends to cause a rotation to the beam. So in your analysis of beam, you need to include the applied moment in your analysis, or else your maximum moment and also maximum shear will be wrong. As for revision also, we already learned about the support. So we have three common supports. We have roller, pin, and also fix. Each of these supports is have a different support reactions. So for example, a roller support, we only have one, which is AY. For example, this is point A, or you want to write as a R, is okay. For pin support, you will have two support reactions. For feet, we have three, which is in Y direction, X direction, and also a moment. Before we go to the analysis of beams, take a look at the beam types. So we have several beam types. We have simply supported beam, overhanging beam, cantilever beam, continuous beam, proper cantilever beam, and also fit and supports. The first three type of beams we call it as determinate beams, while the last three beam we call it as indeterminate beams. What are the difference between determinate and indeterminate beam? So for example, this is a determinate beam. Determinate beam means that the maximum unknown that the beam can have is only 3, because you have three equilibrium equation, which is summation fx is equal to 0, summation fy is equal to 0, and also summation moment is equal to 0. So take a look at the first example, which is a simply supported beam. So this is a pin, this is a roller. Pin have two support reactions, while roller you have one. So the total number of unknown here in the beam is equal to 3. You only have three equilibrium equation, so you can solve this one. So when you can solve the unknown of the beam, we call it as a determinate beam. Same goes to this one, overhanging. Why overhanging? Because the beam don't have any support at end. For this one, this is a pin support, then you have two support reactions. For roller you have one, so the unknown is equal to 3 also. You have three equilibrium equation, then you can solve this one by using equilibrium equation. For cantilever beam, this is a fixed support. For fixed, you have 3 unknown. Contrast with determinate beam, for statically indeterminate beams means that you have more than 3 unknown. Okay, for example, the continuous beam, this is a pin. Pin have 2, roller have 1, roller have 1, so total is 4 unknown. But you only have 3 equilibrium equations, so you cannot solve this one. How to solve this beam? Then you have different method that you will learn in next subject. Same goes to this one. This is a fixed support, you have 3 unknown. This is a roller, you have 1, so the total is 4 unknown. For fixed and support, each fixed you have 3, so then you have ends, then you have 6 unknown. So these 3 example here, we call it as a indeterminate, means you cannot analyze this beam by using equilibrium equation because it's have more than 3 unknown. So for the beam taxonomy that you already learned in engineering drawing, the bottom one is a ground beam, followed by the first beam and also the roof beams. If it is a 3 stories building, then you will have a second floor beam. But this is only 2 stories building, then you have ground beam, first floor beam, and also roof beam. what happened, why we need to learn to analyze the beam, because if you wrongly analyze the beam, then this is what happened: collapse. Okay, all the building will collapse. So as I mentioned in the introduction, beam is one of the main structure of the building that supports all the loadings applied to the building. So as an engineer, you need to analyze the beam carefully and precisely. How to analyze the beam? How to precisely analyze the beam? So you need the shear and moment diagram. Shear and moment function can be plotted in the graph called shear and moment diagram. In this chapter, the sign convention is same as in chapter 1, which is you need to follow the given sign convention. So for example, I'll show you. This is your beam. This is point A and this is point B. You need to cut this segment or this beam in order for you to come up with an equation. How to come up with an equation? You have to follow the sign convention. Okay, for example, this is segment AB. This is a beam and this is segment AB. Then we cut here. We cut between point A and point B. So the sign convention, if you take from point A, this point A, then your V, which is a shear, will go downwards, and your moment will go counterclockwise the direction, and the distance we call it as an x, If you take from point B, this is your point B, and your V will go upwards and your moment will be clockwise. The distance we call it as a x, because in this chapter the distance where to cut the segment is not given, so you need to assume it as an x. From this sign convention, from this x, you can develop the moment equation and also shear equation. The sign convention, if you take from here, which is from your left facing the laptop or your computer, then this is your left, then your V will be downwards, and if you take from right, then your V will be upwards. Same goes to the bending moment. As I mentioned, if you take from left, here your moment will be counterclockwise, while if you take from right, your moment will be clockwise. So this is a sign convention used by all engineers around the world. So as an engineer, you cannot change this one. This is the procedure on how to develop the equation and how to plot the shear force diagram. SFD means shear force diagram, and bending moment diagram, or I call it as a BMD. So first, the cutting plane exposes an internal shear force and internal bending moment. So you need to cut in order for you to expose the internal shear force and also internal bending moment that I explained before. And then draw the free body diagram with V and M satisfy the equilibrium equation, which is a summation Fy is equal to 0 and summation moment is equal to 0. Then you need to develop the shear force diagram and bending moment diagram by the moment equation and also shear equations. Or alternatively, you can use a graphical technique. So graphical technique I will teach you on the next subchapter. In this first subchapter, you will learn how to develop the equations. So this is a procedure of analysis. First, And foremost is the important thing is for you to draw the free body diagram. Okay, and then shows all the support reactions, and then by using equilibrium equation, then you have to calculate the support reactions value. And then after that you have to cut the segment of the beam in order for you to develop the functions or the equations. How to develop the equation? So you need the free body diagram and also by equilibrium equation also. And then when you have the functions or the equations, you can plot the shear force and bending moment diagram. Okay, so this is the same explanation. So we take a look at this example. Draw the shear moment diagram for the beam shown. So this is the fundamental. Okay, so this is your beam. At A is a pin. At B you have a 500 Newton applied load, and at C you have a roller. So can you see this symbol? This symbol means that you need to cut this beam from this direction. So they already give you the direction of cutting in a simple word. If the question did not give you the symbols, then you can cut from left or you can cut from right. It's up to you. But if the symbol is given, you have to follow the direction. So this is a pin, so I put the support reactions. Pin, you have two support reactions, AY and AX. If you like to use R, then you can use R. This is a roller at point C, so I put as a CY. And then you have to use the equilibrium equation to calculate these support reactions, starting with summation moment at A is equal to 0, clockwise is positive. Why I take moment at A? Because A is have more than one unknown, so we take moment at a point that have more than one unknown. So summation moment at A equal to 0. My definition is clockwise positive, then I have 500 times the distance, which is 2.5, minus CY times 5 is equal to 0, then CY is equal to 250 Newton. And then summation FY is equal to 0, upward is positive, then you have AY minus 500 plus CY that already calculated, which is 250 is equal to 0, then AY is equal to 250 Newton. Don't forget about the summation Fx is equal to 0, to the right is positive, then you have AX is equal to 0. So this is a support reactions, how to calculate the support reactions. And you have to develop the equations. As I mentioned, you need to develop the equations segment by segments by follow the sign convention. So this one you have segment AB and segment BC, so means that you have to cut 2 times. Okay, because you have this symbol, then we follow this symbol, means that you have to cut from A, segment AB and segment BC. So put a dotted line. For segment AB, the range of X value, so X should be more than 0 and less than 2.5 meter. This is referred to the diagram. So when you cut from A, you need to follow the sign convention. So this is your beam. At A, you have a support reaction which is 250 Newton, and this is point A. Then you cut here. When you cut here, you expose the internal forces, which is V downwards. You can put as a Vx and Mx. Okay, the distance, because since we didn't know the distance, so we put it as a x from the first point until the cutting point. So we put the distance as an x. So how to develop the equation? Then you have a summation moment. So I put it as a small x. Summation moment at x is equal to 0. Clockwise is positive. Then when you put the moment at 0, you take moment at 0. Then you have positive 250. The distance is x. And then what else? You have minus mx is equal to 0. As I mentioned, you can put the notes here. So you put notes here. This is your F and this is your D. So M is equal to F times D. D should be perpendicular. And then you have an equation for moment. Then we do the same for summation F1 is equal to 0. Upward is positive. Then you have 250 minus Vx is equal to 0. Then you substitute the value of x here and here in the equation. When x is equal to 0, moment is equal to, you substitute the x value in this equation. For moment equation, 250 times 0 minus mx is equal to 0. And then V is equal to 250 Newton. Then when x is equal to 2.5, your moment is equal to 6 to 5 Newton meter. And V is equal to 250 Newton. Okay, you substitute the value of x here. Substitute x value in equation. Okay, do we need to expand this equation? The answer is no. Do not expand the equation, because I'm afraid that when you expand the equation, you might be wrong. So you just leave the equation, no need to expand. And then you do the same for segment BC. Segment BC, that's your segment BC. Since you have the symbol, so you need to take the beam from A. So this is your A, which is the value is 250 Newton, and at point B you have 500 Newton, and this is point X, small x. The distance from A to B is 2.5 meter, and then the x value is from a starting point, which is the first point of your beam, until the cutting point. Okay, so you cannot take x between B to point X. No, okay, the x, the distance should be from the first point of your beam until the cutting point. Okay, so here when you cut the beam, you will have the sign convention, which is V downwards and M is counterclockwise. Okay, same steps. Then you take summation moment at x is equal to 0, because x you have two unknown. Clockwise is positive. Then you have equation, moment equation. So you need to calculate by yourself this one. And then summation F1 is equal to 0. Upward is positive. Then you have the shear equation. Okay, and then when x is equal to 2.5 meter, and what is your M value and what is your V value? When x is equal to 5, what is your M value and what is your v value. Okay, and after you have both function, then I advise you to make a table. This is two segment, this is segment 1 and segment 2. Easier, but if you have more than 5, for example, segment, then it's very confusing, so I'd advise you to put in a table form. So you put a table, segment x, which is a distance, v value, which is a shear value. Make sure you put the units, and moment value. The unit depends on the given question. First you have segment AB, and then you have segment BC. Since x you have two distance, then you put another rule here. Same goes to this one. For segment AB, the range of x value is between 0 and 2.5. For segment BC, should I use different color? Segment BC, you have 2.5 and also 5, as if you already calculate all the value. So when x is equal to 0, v is equal to 250. When x is equal to 2.5, v is equal to 250 for segment AB. And for segment BC, when x is equal to 2.5, your v is equal to negative 250. When x is equal to 5, then your v is equal to negative 250. This by calculation at segment BC that you need to calculate by yourself. And for segment AB, when x is equal to 0, m is equal to 0. When x is equal to 2.5, then your m is equal to 6 to 5. For segment BC, when x is equal to 2.5, then your m is equal to 6 to 5. When x is equal to 5, your m is equal to 0. Okay, after you done with the table, then you need to draw shear force diagram and bending moment diagram. Before you draw the shear force diagram and bending moment diagram, you need to draw free body diagram, shear force diagram, and bending moment diagram. So this one should be in one page. Don't put it in the separate pages. So first you need free body diagram with all the support reactions value. So this is point A that you already calculated, 250, 500 Newton. At point C is 250 Newton. The distance is 2.5 meter. 2.5 meter. This is point A, point B, and point C. I advise you to put a line for each. Okay, so we start with shear force diagram. So this is your axis. Put the level for each axis. Okay, and then you can plot. So according to the table, when x is equal to 0, so this is 0, this is 2.5, this is 5. When x is equal to 0, your x is equal to 250. When x is equal to 2.5, you have 250. When x is equal to 2.5 for segment BC, you have negative 250. Then when x is equal to 5, you have negative 250. Then you connect all the points. So at point A, you have the separation, which is 250 output, so it goes up here to this point. And then you just connect all the points. Then because here you have 250 outputs, then negative 250 plus 250 is equal to 0. Then you close the loops. So you can do for shear force. Okay. Take a look at the example 5.2. The question asks you to draw the shear and moment diagrams for the beam shown. Magnitude. So at this is a point A, this is point B. A is a pin, so pin you have two support reactions in Y and X direction. For B, you have the roller support, then you only have one support reaction. So for this one, same, you need to calculate for support reaction. Solution that did not give you how to calculate the support reaction, then you have to calculate by your own. And then since they don't have the symbol of the cutting, this symbol, so you can start from A or you can start from B, it's up to you. This is a UDL, so you need to know how to solve for UDL. So take a look at the solutions given. So they already calculate for 6 kN support reaction, and 3x is how you solve the UDL. From moment, you know that moment is equal to force times distance. So this is the force and this is the distance. Force and distance, then you get this moment equation. Then you can plot the shear and moment diagram. Please study how they get this diagram. Okay, same goes to the next example. So you can read the solutions. So this is a linear distributed load. So I would like to teach you how to do this beam. Read the question. By using shear and moment expression, draw the shear force and bending moment diagram for the beam. So here at B is a fixed support. Fixed has how many support reactions? This has 3. By, Bx, and also a moment. How did I know the direction of the support reactions? I assume when you calculate, if you get the negative value, mean it is a opposite direction. Okay, we solve for the support reaction. So you already draw the free body diagram here, show all the support reactions. Then we can start with the support reaction calculation by taking a moment at point B. Why moment at point B? Because it's have more than one unknown. So I mentioned moment at B is equal to 0. Clockwise is positive. Then I have 2 kN goes to B. So I will show you if you did not understand how to take the moment. So this is our point of rotation at B. So this is our force, 2 kN. So this is the direction. So it is downward, so it goes here and then goes to B. Same goes to UDL. Everything goes to the B because you take moment at B here. So you need to know which one is positive, which one is negative. If it is rotate clockwise, mean it is positive because we have our definitions here. if it is rotate counterclockwise, then means it is negative. Okay, so we start with 2 kilonewton point load. It is positive or negative? Negative. Okay, negative 2 times the distance 2b is 4, and then minus, how to solve for UDL, 1.5 times 2, and the distance is 1/2 times 2, and then minus MB is equal to 0. Then MB is equal to what? Okay, and then when you get the MB value, then calculate for BY. Summation Fy is equal to 0. Summation Fy is equal to 0. Output is positive. Then you have negative 2 because it is downward. And then minus 1.5, which is the UDL. And then this is how you solve the UDL. You have to time the distance. And then plus By is equal to 0. And then By is equal to what value you have to calculate. And then don't forget the Px summation Fx is equal to 0. To the right is positive. Then we have Px is equal to 0. Okay, so this separation is very important. If this one is wrong, then all your calculation after this onwards will be wrong. Okay, so we've done with the support reactions, and then you have to cut the segment. So I erase this one. So to cut the segment, since this question they did not give you any direction of cutting, then you can cut from left or cut from right. It's up to you which one is the easiest one. It's up to you. Okay, as if you already calculate the support reactions here, then you will get the value for By is equal to 5 kilonewton. Bx is equal to 0, and moment you will get negative, so you change the direction. So you will get 11 kilonewton meter. Okay, so this one they did not ask you to cut from where, from left or from right, so I cut between A, so I name it as a C, AC and CB. Okay, then you draw the free body diagram of each segment. For segment AC, the range of X value is between X should be more than 0 and should be less than 2 meter. Okay, see the distance. And then with your hand you close the dash line, then you just draw what you can see. So I take from A. So this is my beam. So this is my point A. At A I have 2 kilonewton. And then when I cut here, I name it as a small x. Then I have V and also moment. This is the internal forces that I expose when I cut the segment. Okay, same. By equilibrium equation, you can come up with an equation for moment and an equation for shear. Summation moment at x is equal to 0, clockwise is positive, then don't forget the distance. When I take moment at x, I have 2, negative 2 times x minus mx is equal to 0. And then I do same for summation Fy is equal to 0, output is positive, then I have negative 2 minus Vx is equal to 0. Then I substitute the x value into the equation. when x is equal to 0, m is equal to 0, and v is equal to negative 2 kilonewton. When x is equal to 2, m is equal to negative 4 kilonewton meter, and v is equal to negative 2 kilonewton. And then with the same steps, you do for CB. The range of x is between 2 and 4 meter. So x should be greater than 2, should be smaller than 4. So you draw the free body diagram. It's up to you. Either you want to take from left or from the right. Okay, so we have 2. If I take from left, which is from A. Okay, so you have this free body diagram. You have, this is point A. You have 2 kilonewton. And this is point C. This is half UDL, which is 1.5 kilonewton per meter. So this is point A. The distance is 2 meter. And from A to the cutting segment, the distance we name it as X. So when you cut here, then you will expose the internal forces, which is V and also a moment. But if you take from right, which is from B, then you have this free body diagram. It's up to you which one you want to follow. Either one will be correct. You should get the same answer. If you get the different answer, then please check your calculation. So this is 1.5 kilonewton per meter. The distance from here to here is X. So when you cut here, you will expose the internal forces. Please follow the sign convention. Which is, if you take from right, V is upwards and moment is clockwise. Okay, so this one is from left. So you have this free body diagram, and this is from right. You have this free body diagram. It's up to you. Either one. Okay, you solve this one, then you will get the equation of this segment. So give me the moment equation, and what is the V equation. This one, what is the moment equation if you start from right, and what is the V equation if you start from right. You just choose either one. No need to do both. You just choose either one. Okay, after you get the equation, you can put it in the table, or if you think you don't want the table, then it's up to you. Okay, and then we draw the shear force and bending moment diagram. At point A, you have 2 kilonewton, and this is point C, and you have a UDL 1.5 kilonewton per meter. And at B, you will have the support reaction that you already calculated in the first step, 11 kilonewton meter. And then put the distance 2 meter and 2 meter. As I mentioned, you need to do this in one page. So you already have the free body diagram. Then draw the line, draw the dashed line. And then do an axis for this one, this is free body diagram. Now is shear force diagram. So don't forget the axis label. Meter for shear force is a shear, then kilonewton. At the bottom here you do for moment. Okay, then we plot. Before that, put the distance. Okay, so you have an x is equal to 0. Your v is equal to negative 2. This is negative 2. When x is equal to 2, v also negative 2. When x is equal to 4, v is equal to negative 5. And then you can connect the line. Because at point A you have 2 kN downwards, so you move down until this point, and then negative 2 to negative 2, straight line. And here you have a UDL. So when you take up the equation for segment CB, you can see that this is a quadratic equation. So for quadratic equation, it should be a curve. Okay, so you join this, it should be a curve. This one, this part will be the straight line, but for UDL it should be a curve. And then here you have negative 5, here you have 5, then you just put it up, because negative 5 plus 5 is equal to 0, then you close the loop. Okay, same goes to bending moment diagram. So when x is equal to 0, your m is equal to 0. When x is equal to 2, your m is equal to negative 4. When x is equal to 4, your m is equal to negative 11. Okay, again, you connect all the points. So since here segment AC is a point load, then take your ruler and then do the straight line. It should be straight. But for segment CB, it is a UDL, then you make it a curve, a little bit curve. You adjust the point if it's not touched, because this is just a sketch. And then you have negative 11, but here is 11 clockwise, mean it is positive, then you close the loop. How to know either your answer is correct or not? If everything is equal to 0 at the last point. If it is equal to 0, means that all your calculation is correct. If it is not equal to 0, then maybe something wrong with your calculation. Maybe in your first step, which is a support relation or an equation. Okay, you have to recheck. And then from here, so you have to take out the maximum V is equal to the highest value, which is 5 kilonewton. Okay, this is the maximum value, and also the maximum moment is equal to 11 kilonewton meter. This one. Okay, you can try this one. This is a linear distributed load